great reasons for some of the general education classes here on campus to go online, especially the algebra sequences. They're prerequisites. Typically, they don't require quite the infrastructure that the students need once they get into the programs. What I wanted to talk about, however, are some problems that have arisen by moving math courses specifically totally online. And what I'm going to propose is the move from the emphasis in traditional classes from the technology being calculators to then online courses having the iPad in order to fill in some of the human-to-human contact that you get in a math class. It's hard to replicate with online courses as they're implemented now. So I'll be using iPad and then our new LMS, the Canvas system, to demonstrate written assignments. So first of all, the problem that's basically widely acknowledged, it hasn't been studied very much. I found some citations that I put down here, but basically with web-based homework, my math lab being the example that we use here, there's a pronounced difference between the student's ability to do those problems. They can do 90 percentile or above on all their homeworks, yet when they come in to do an in-class exam, a simple assessment on the very most basic problems, many teachers here and also in the literature have found that students who have done strictly online homework are unable to do the most basic written assignments, which is the way you would use mathematics in any of the programs. So now that's not so true when it's truly hybrid, so that the additional practice you can get with the feedback, the instant feedback on in-class assignments, online assignments, those actually can supplement as long as they're getting this human-to-human and written aspect of the homework. It's really when you're entirely online, as is being encouraged to be done now through online classes, that the gap appears. And again, that gap is they can do the online homework, they can't do the actual physical mathematics, this live problem-solving skill, which is exactly what they're supposed to have when they come out of these courses. Another problem is that the web-based homework, the interface is not very human. It needs very precise and very exacting input. And it's actually led to students, basically a higher attrition rate that's been documented in online math courses, especially with students who do struggle a little bit with mathematics. So again, some of the evidence is anecdotal, as is, I hear that quite a bit on campus here, and it has started to appear in the literature. In other words, basically the translation of ability online does not come, or doesn't show up in terms of ability in in-class assessments. But really more quantitative studies should be done on this. Of course, the online homework is constantly changing. They constantly try to improve it. So this has to be sort of an aggressive and up-to-date study. You can find things that are even 3 years old and that wouldn't be representative of a comparison relative for today. So what do these online homeworks not provide? Currently, they don't obviously have live written sessions so that you would have in a classroom where I walk around and watch students doing their homework and give them instant feedback, which is basically, because we have such large contact hours and in-class time, it's basically like a private office hour if you structure your class correctly. So it's missing that. And then the thing that I want to talk about is this lack of a realistic or practical interface to show written work, which is a key component of the conceptual understanding of mathematics. Getting the right answer does not necessarily mean that you understand your own thinking about that problem. So let me just show you how it exists right now. So in my math lab, if you want students to show their work, when you set up a problem, you can click a button here and say, show your work. And so what does that look like to the students? To the students, they go to a problem here, they're doing a simple logarithm problem, and up comes a palette, a window, a canvas here. But the only way to enter mathematics here is to use this huge array of palettes of symbols. And this is the kind of thing you do when you're going to publish a book. It's not the kind of thing you want a student to do. They're not typesetters, and yet the interface is asking to do the same level of complexity entering. And so for this simple problem, you might have to pull up a palette for parentheses just to, it would take a microsecond almost for them to think about it almost intuitively, without any disruption. They do that symbol. Here now, it's actually disruption in their thought process. They have to go here, look for the right symbol, they've forgotten about the problem momentarily, and they come back to it. This is a huge impediment to actually thinking about mathematics. So it's distracting, it's time consuming. I mean, this took me to do this simple solution here for a very simple problem. It took me 3 or 4 minutes. It should take maybe 10 seconds, 15 seconds in class. In terms of the difference in time. Of course, it takes time to solve the problem, whether you're doing it in paper and pencil, or here I'm talking about just the difference between the written technology, just the old-fashioned pencil and paper versus these palettes. And then finally, it requires complete confidence in the understanding of symbols, because it is so binary here. It's either the right symbol or it's not. Whereas with written, they can kind of get 80% to the right symbol and then can be assisted, and I know what they mean, and then you can give them sort of incremental assistance on the use of symbols. And then finally, when they actually go to submit this written work, it's just right or wrong again. Okay, so that completely removes the motivation for them to interact with me. They got it right, great. Okay, I don't care what the instructor has to say about my writing. So they're going to ignore my writing because they know that they've gotten it right. Or if they got it wrong, they still might not look at their feedback because they think of it as being completely incorrect. So basically, self-assessment is something that's completely missing from this because they're looking for a right or wrong answer. They're not thinking about, well, let me look at my own work and see, does this look reasonable or not? This really discourages that sort of, whatever you might want to call it, like metacognition, thinking about thinking. So anyway, the show work I find is basically ineffective, and I haven't asked them to do very much of that. Even the publisher themselves warns against assigning too much show your work. So, because they've gotten so many complaints about it, evidently. Okay, so how are we going to fill this gap between online homework and realistic written work that you get in a traditional course? Basically, you want to supplement online math courses with targeted, because this is going to take a lot more time. Instead of being able to work with 26 students at once, you actually deliberately have to shift your focus to each and every of those students and then multiply it by 26. It's inevitably going to take more time online. So if you do it targetedly, you still want to have some interface that's more intuitive than the one provided by the publishers. So what we want is something that allows you to submit the work electronically in a systematic and easy-to-use manner that has a great human-computer interface. This will allow us to provide valuable feedback. Again, this conceptual learning that's so important for mathematics, and also some of the basic skills of really learning physically how to write symbols, which aid in the understanding of mathematics. And then finally, there'll be a greater focus on the problem-solving process itself, not simply getting the right answer. Because once the people use, or the students use the mathematics in their programs, they will have to know whether, or have this assessment, self-assessment of whether or not they're on the right track or not. And they won't be given sort of binary correct, incorrect all the time. So traditional approaches that you might think of, well, I'll just set up a whiteboard and have a camera. And they'll have a webcam and they'll be interacting with me on their own whiteboard, and we'll go back and forth. The problem with that is it's costly to replicate a classroom for each and every student. That's basically what you're doing. And it's going to a huge amount of time. Costly not in terms of money, but in terms of time. There are online whiteboards, but I kind of explored a few of these. The technology for the online whiteboards, they're synchronously updating each person's whiteboard on something like an iPad, but it needs to be hosted somewhere on a server, and that costs money, and they have subscriptions. So, and both parties have to buy into a subscription. It's like getting a cell phone plan. So that's not really practical. So then the other idea is basically just to exchange images of written work. So a traditional method would be a photo or scan of a document. Teachers here have used this. You run into some problems with this. So you could either send those documents via email or directly upload them to an LMS. And there's some discussion of the importance of how this can become, if it's cumbersome, can become so static, so out of date that the students don't even respond to the feedback that you send them because too much time has elapsed. Okay, so it has to be fast. So here's an example I did with a student for this quarter. They took a photo using their handheld camera. They sent me their problem. One of the technical troubles with this sort of traditional approach is the file sizes are huge. So if I want them to send me like 3 problems, they have to send me 3 emails. They get frustrated, they stop doing it. Again, this asynchronicity takes too long for me to give them feedback. You can improve it a little bit by, instead of emailing, you can upload it directly to Canvas or some other LMS. So here's some annotation editing in this. Obviously you wouldn't do quite as much writing as I did here, but this is just sort of traditional methods of downloading it to a PC and opening it up in some sort of PDF editor or photo editor, and then typing and marking it up in various ways. Again, the poor image quality here prohibits me printing it out because I'm going to waste so much ink on all the dark. The white balance here is completely off. It becomes very expensive in terms of ink and paper, so I don't want to be printing this out. So we're left with using some PC software. Of course, there are many interfaces for working with traditional computers that are powerful. They're highly customizable, but there's a steep learning curve unless you already know how to use all these tools. Adobe Acrobat would be the simplest way to annotate. The reader itself, that's free, has basically very limited editing capabilities, so you want the professional. Again, with the professional, you lack a lot of drawing capabilities that you have on actual photo editing software. And also, you don't have any way to enter mathematical symbols very easily. So you might turn to Adobe Photoshop, which allows you to embed on different layers over the image, graphs, equations, everything. It's very powerful, however, there's a huge learning curve for this, and it's expensive software that you'd have to already have. Otherwise, it would be impractical. So the advantages are for PC annotation and this exchange of images are that there's a full suite of editing options and it's very powerful. The disadvantages, the interface is inefficient, expensive, and requires too many skills and tools. It's really inappropriate for the purpose of a quick feedback, and that's where tablets come in. Specifically, we can look at iPad as setting the standard, the gold standard for tablet technologies in terms of excellent human-computer interface. The iPad and other tablets provide excellent interfaces for handwriting. They're easy to learn. They're still asynchronous in terms of they'd have to send me their handwriting and wait for me to feedback, and you give them feedback. So, but it's so simple that some of that time delay is going to go away. So the simplicity of mobile application software over these PC applications is the real strong point of part of the human-computer interface of tablets over traditional computers. And the apps can be directly linked to an LMS, so it's easy for the students to learn how to submit with maybe a 5-minute YouTube video or the like. So what's required materials? A tablet. It's expensive, about $400, $500, depending on which tablet you get from Apple, but they're as low as $200 now from Google directly. The cost is likely to go down. The apps themselves are free. Here's the issue of cost. Again, just for comparison, we've had no troubles buying copious amounts of these calculators here. A single app that's free can do everything that these calculators can do, plus a huge amount of extra. Well, basically there's an infinite number of apps that you can add on to this device and make it much more powerful than a calculator. And that's not an insignificant cost, just shy of $200 for some of the ones we have on the shelf out here. And so for that, you could get a Nexus. So the demonstration here is specifically using the iPad plus Canvas. I'll just show you quickly the apps, how you configure them, and then just a simple demonstration. It'll just take a minute or two, and then we'll evaluate or ask you to help me evaluate, basically, and see what you think about this. So basically, you go to the App Store. This is what a student would do. You can make a little YouTube video about this process. You would instruct them to go to the App Store, search for the Canvas instructor app. There'd be two options that show up here. You select that one, you download it, and then you log in. And that's specific to the institution. For BTC, it's quite easy. And then their courses would show up. And so I created a dummy course for this presentation called Perkins Math Course. It opens up, and then basically it's already configured. So it just takes a couple of minutes. It's easy to teach to students. Or you can even have it all set up for them before they check out their iPad. But a lot of them will have their iPad already. So you want to produce some sort of instruction for that. And then the best annotation software that I have, and this is really crucial for mathematics, that it has a feature I'll show you in a minute. The app that I found that was not only the best, but also free in terms of opening up a single, or I think up to 2 documents at once. It's free to do that. If you want to open more, you have to pay $6, but they're only doing one homework at a time, and $6 is not a big cost anyway. Anyway, that app is called GoodNotes. The most important feature of it is that it has a zoom type tool, and most note-taking apps don't have that. It has a bunch of other standard editing features here. Okay, so I'll show you what that zoom tool is in just a second here. So the student would go to their schedule of homework, and they find a homework that I've posted and download it. And they'll click on that link that's in the bottom of the assignment. It will open up I did it as a PDF here, small file format. They can't actually change the original problem, etc. There's a lot of reasons for using a PDF. They'll open up that PDF in Safari, first of all. So you send it from the Canvas app to Safari. It's pretty easy, you just follow the breadcrumbs. And then from there, from Safari, you can send it to any app. Specifically, they'll send it to GoodNotes to begin editing it. And then they open it in GoodNotes. And this is basically the simple interface of GoodNotes. It doesn't, compare this to Adobe Photoshop, which had palettes and all kinds of tools that are a distraction again. I'm trying to eliminate distraction with the palettes in the online homework. Here there's very little distraction. Just a few tools on top. Specifically, they have a pen, they have a highlighter tool, they have an eraser. That's standard on all note-taking applications that you can find out here. What's unique to GoodNotes is, here's a lasso tool, so if they want to select a bunch of text at once and do something with it, they can do that for sure. But the feature of this that's really important is the zoom tool that you see here. It will create a box in a section of this, and you can make it larger or smaller depending on the zoom level that you want. And it creates a high resolution part of that screen, which then is on the same scale or size scale of the finger for writing mathematical equations. And so this was the key feature I was looking for, and luckily it was out there. So you can select the color that you want to write, which is nice when you're giving comments. You can select different pen colors. So it does replicate what you would do in class with different dry eraser colors of pens. So here's an example of writing. What you see is in Zoom box, it makes it very easy to write long expressions at a very high level of detail so that the whole expression of mathematics can fit on the width of a piece of paper, just like you would in a physical piece of paper. As you move out of the Zoom box, it has an auto advance for the Zoom box, so it will follow you along. And it's very easy just to look up here for the context of the equation. So when you're writing mathematical expression, it's important to see the whole context of the problem as it's evolving. So if you didn't have the zoom feature, you'd have to have very fine motor control, and it's very difficult to write and fit everything into the space. With the zoom control down here, it accommodates the size of the finger to write at the level of detail to fit a complicated mathematical expression in the width of a piece of paper, yet it also allows you to refer very easily by a glance upward to the context so you don't lose where you're at in the problem. And all of this is essential for doing mathematics. And again, you can use different colors of ink, and you'll see that in all mathematics textbooks for showing the key step in each stage of the problem solving. So that's very important. So when they're done, however far they get, they basically click on the 3 dots here, the ellipsis, which is standard in all apps, or many apps, in terms of sending content out of the app that you're in. They send it out, basically, to an external app here. And it's kind of a 3-button press to get to that point. Again, you could create a YouTube video to show the students how to do that. You could ask them to rename it just for keeping track of which edited version they're on. Canvas also, I think, can timestamp it, so they don't have to do that. At any rate, once they are ready to export it, they export it to the Canvas app, which they've installed. And so without having to go to a computer or anything else, they're still on their iPad. It gets received online in the cloud, and the Canvas LMS says that it's been received, and then they basically upload it to send it to me. Once it's there, I can view it. Oh, actually, here they're selecting it. It comes in as an image in their photo bank. So they'll select the document, and then it's submitted. And then I'll get an email within seconds, and then I can start editing it. And then I can do the same process to give them feedback. I'll go to that person's homework submission, I'll open it, and I'll do exactly what they did on my end. So it's no more difficult for me as an instructor. And what's nice about this is it's very easy to draw in a nice curve. If I want to show them, look, think of the geometrical aspects of this problem. So I can do exactly what I would do in a classroom with a student. Who responds better, let's say, to graphics? Some students respond better to text, textual cues. Some students respond very well to graphics. So I can incorporate that very easily. Just drawing. And then finally, here's a much more complicated interaction that you're seeing here that typifies a classroom experience. You can also type, no problem. You can add geometrical shapes and good notes, and just very, very simply. All right. Now, of course, that took a very long time. In practice, you wouldn't write this many comments. So the advantages are this is very easy to learn. I'm new to the iPad. It took me minutes to learn. So if I could do it, I basically am giving. I think some of the students are even more skilled with these devices than I am. So I think with a YouTube video or whatnot, and basically the hardest part being the setup, I think this is very feasible for everyone to learn. They're free apps, and it's integrated with Canvas. So in order to speed up the process. So the disadvantage is that these devices are expensive. Again, you have to put that in the context of calculators, which are very expensive. And we've been able to raise money for that. So, there's some ideas that you could have about this, like a course fee, so that students who have them already, they don't pay like a rental fee or something. I don't know, there's ideas to raise money to keep these updated. Another disadvantage is it's not completely synchronous. They do have to wait for me to write in comments. It does take me a few minutes to do this. And again, the whiteboard apps are really not there yet. And they also have an additional cost of a subscription. And it's still very time consuming. So that's why I said these have to be targeted homeworks. In-depth problems they do maybe once a week. So if you spend 10 minutes on each student, you're talking about a 2-hour correction feedback experience. Although I think it would be more fulfilling than a lot of times with written homework where you do spend that time grading anyway and you hand it back to them and you don't know what happens with it. So here I can see whether they viewed it, ask them for further feedback. Do you understand, do you not? So there's some advantages to the online format despite this time-consuming element. I'd like to say basically an app that's a portal to a web-based applet or Ajax-driven website where it's just a whiteboard that has pull-up palettes for some of the mathematics using a mathematical input that all mathematicians know. It's called LaTeX. So I can type in a symbol when I want to type very precisely so that the symbol I'm writing looks perfect, so there's no ambiguity. I want that to be something I can pull up as an instructor. I want it to be synchronous, so like a real chat session where they can handwrite. And even there could be some character recognition. So definitely with Chinese, they figured out how to do character recognition. There's a little pop-up window they can pick out the character. So mathematics is very similar to that. The difference in mathematics is that it's inherently a two-dimensional character recognition problem. Something being on top of something else has, let's say, significance, whereas languages are basically one-dimensional. Text goes in one direction, whether it be top down, right to left, or whether, like in English, is top down but from left to right. It's still a one-dimensional character recognition. So mathematics is more challenging. Just to sort of as a side note, there's a lot of research being done on ideas that this is actually a really interesting problem, like recognizing characters. So but that's coming along very, very quickly right now. Anyway, so I'd like to see some more synchronicity in feedback if we're really going to go online with mathematics, real-time feedback, and it'd also be nice in terms of assessment to have things timed and even observed. So that's sort of how far I got on this. There's a lot of infrastructure already there, and I think it shows some promise. And I think the students would enjoy actually interacting with this device. So people who have Apple devices tend to like to work more because they actually enjoy being with them. So we can leverage that as teachers. I can, if there are any questions, I can show how to do that, actually on the app.
So when do you plan to roll this out?
I tried to do it for this quarter, but you know, there has to be lead time, and we have to have enough for the students in the class. But it's so simple. I mean, I had it set up before. It's really nice. So I don't know. I think there's probably a lot of alternatives as well. There's the one using the tablet that I came up with. That was quite good.
Is the app also available in the Android?
I was just searching for that this morning. I believe it is, or something very similar. But I'm not. Yeah, I didn't have time.
It'd be nice to have cross-platform.
Exactly, especially for that price point of the Nexus and
right.
other similar devices, which is basically less than half of this. But here's an example of this thing. So the zoom box is what's important. If I'm trying to write here in just the level of zoom of the whole page, which is what they're working on, it's hard for me to make this small enough to fit this problem on here. See, it's just too big. I've already used up way too much space. From experience, I know that's too much space. So let me erase that. And let me go back here to the zoom box now. So now I have, oh, you can't see that here. Let me show you the camera. It's not mirroring completely, so I don't know if you can zoom in on that.
Oh, no, we can do a screen cap later.
Yeah. So I'll show you guys here. So now I can write, it's so much larger, I can very easily get this down to the scale that I need. Right? And I like that this has an eraser so I can improve parts of it. I don't have to start over. Some of the apps don't let you do that. Not too many of them anymore. People figure it out.
You need to grow your fingernails.
So where?
I don't know, does it need the pad of your finger?
Yeah,
you can use
I
a
think
pen
it-
is what I was
So,
going to say.
yeah.
Yeah. But even with a pen, it takes some skill to get it detailed.
But in
Well,
the
you
Zoom
know,
box,
you're taking a class.
Yeah, but if you're zooming, right, you can.
The zooming is
yeah,
everything.
And they can use a pen, and then
Yeah,
that's
and
a key feature.
There are whole reviews on these note-taking apps, and the zoom feature is really the thing that sets the really good ones apart from the not-so-good ones. Yeah. So that I found that's what I was looking for, and I found it. It's really essential. And what's nice is also you can hit a oops. I don't know why the whole thing isn't showing up there. It's just showing me the page. I don't know why it's. I guess I'm good on a note-taking thing. It's really just mirroring the underlying sheet. It's not mirroring the whole app. But there's a little graphics button here, and it'll recognize shapes. So if I wanted a coordinate axis for plotting a graph, it'll recognize that's a straight line, and it'll straighten it out for me. And then I can take that off, and I can sketch in the exponential function, and I can label this, f of x is equal to e to the, and then if I want to move this over, I can go here, 2x. And what's nice is I still see the whole context of the problem here. You can do it in the zoom box. I don't know where I'm at. I've lost myself in the detail of the problem, but I can do it very easily. So, and the gestures work down here as well in terms of moving around and zooming. Oops, there's an undo button as well as an direction. And you can shrink the box if you don't want it. You just want to like very, very detailed. Anyway, I found this good app, and it really made the difference, because none of the other ones I found, it's interesting how one key component makes a difference between something working and not, and this was essential.
And which one is that?
It's called Good Notes. It's free for 2 documents open or on the book. It kind of looks like a bookshelf, like this.
Yeah, the iPad, the AirPlay stuff doesn't mirror everything perfectly. It's like, it changes by the app, so.
I see. So
it's not perfect mirror.
So it kind of shows like iBooks. If you have that app, it shows up, the documents you accumulate here show up. So if you pay $6, you can have an infinite number, well, until you fill up the memories, the flash memory or whatever. But, if they're just working on a homework at a time, they just have to, hit the edit button and delete the one, just delete this one that they're on. And then they can free up the queue.
So as far as you were saying, when they took pictures of their homework, that
Yeah.
massive file, it was like 2 megabytes per picture or something, right? But this far reduces that.
Yeah,
It's a lot easier to submit.
After I was done with all these comments, so if you look at the complexity of this last document here, so you can see how much I've added to all this graph, a bunch of text, color, all this stuff. This came out at 1 megabyte. after all that. The original one was just a few kilobytes from the student.
And that's easily printable too, compared to the.
It's easily printable, it puts the resolution where you need it.
Yeah.
It's not doing high resolution on some of the lines. It is doing very high resolution here, and it's also, that stuff is PDF.
Yeah.
It's vectors. So this is vector text, so this is, bitmapped, but it only has just enough so that it's perfectly legible on an iPad. And they can print it for their own reference, if they're forming a learning portfolio, let's say. And you could actually encourage them to do that, but they don't have to because they might not have access to a color printer and not want that added expense.
Nice.
So for a math class, it actually be a significant cost.
I mean, it would be ideal to be able to provide that much feedback for every problem on somebody's homework, but
It's impossible, yeah, exactly. So,
Yeah.
Possibly.
so anyone taught, it's not. So what's nice is you don't
I
have to
mean,
do
it would
any
be
of the typing.
ideal, it would be wonderful.
So all the text stuff, obviously, don't have to do any of the text. That's more for demonstrations. So the writing is actually really fast. It's just like you would do on a written homework that you'd have to do anyway in a traditional class. So if you can stay away from text and you just do quick sketches, quick hints, and ask the student to actually put in the time to give a secondary feedback, that might be actually more feedback or more useful for the student to do self-evaluation. It's going to give them some hints. This is kind of more for purposes of showing you how much you can actually jam on a page given this sort of note-taking application. It's not true of all of them. And I'm sure there are going to be more. I think I just checked this morning, there's a competitor, but they were missing the Zoom tool. So that was
And I
key for
don't
math.
see anything on Android.
Yeah.
There's gotta be some equivalent that you can find.
It's probably, I'll have to,
And they're increasing every day, so.
we can write one.
I was gonna say, you guys got to make one.
Your spare time.
Yeah.
Yeah, what's that?
So I like how easy it is. Just one app, and they'll probably have Canvas already. And either they come to check this out, you'll have it all set up for them, and then they just have to log in. Or it's easy to make a 5-minute YouTube video showing them exactly what button to press, and it's exactly what it's going to look like for them because you can replicate it here.
They can come to the library and we can help them.
Yeah, and the calculator really can't do this, and this is a free app. So this
That's
is
sweet.
Wow.
3-dimensional printing, or just one of the many things of this graphic. So if they were using this anyway, you argue that they're having a better experience,
I think you could also say that the transferable skills that they're developing using that device
Are better.
They're
But,
much higher quality than learning to use the symbol buttons and all the different editing tools
Right.
in a PDF.
So what was,
Yeah.
what was that 3D?
This one is, how do I get back here? It's called, it's this good grapher. It has this, you'll see this parametric plot come up. There are so many, I always had trouble telling students, but this one was really great. And it actually has it, although it offers so much power, it has an easy interface for just a plain old calculator.
Good grapher, good notes.
Everything's good.
And then it copy calculations, email calculations, so you can actually have them do some work that way.
What I'm seeing now is essentially a tape, right? As you go through, it'll show the progress. Yeah, like an old school like 10
Yeah.
right?
Yeah, exactly, which had its virtues. I mean,
Yeah.
it's written work. I mean, our biology hasn't changed. We still interact with physical objects, and the more these devices can replicate at least some of that, I think the less they get in the way of the actual learning.
Enjoying the process behind the math as you're
Right.
talking to, as opposed to just the final answer.
And that's so important, because they need to know that they've gotten the right answer. And it's only because of logical steps.
And part of that physicality, that, 40, 50 years ago we relied on, right? That actually helps that brain processing and that memory piece.
Yeah.
It's so true,
Because
yeah.
you put it
It's
in
like
your
kinesthetic.
physical body, that's right, and you remember stuff in ways that you don't.
Yep. So the other thing that I was thinking of was also to, use a spreadsheet app or just, the online Google Docs. Instead of making little tables on a piece of paper, here's a place where the online might actually be improved. Instead of making a table to put, so when you're graphing something, you make a table of inputs and outputs, and then you graph it. So one skill they could learn in the context of an online class would be to go and instead of using the calculator to fill in the numbers in the table, to learn a little spreadsheet usage in the context of an algebra class, which is a transferable skill. They can learn how to enter a function. And you can actually teach a little bit of the concept of function long before you introduce the formality of that, because they see that there's a relationship between this box and that box, input, output, which is kind of the cornerstone of functional understanding
And
relation.
in my experience, BTC students had more trouble than I had ever encountered before making that leap between that intuitive graphing picture, piece and an abstract, equation. Most students in my experience, once they had that graphing, it's like everything opened up for them because they sort of naturally made that connection.
Yeah.
BTC students, it's harder to do that, and even though most of them are, visual spatial, and they live in the concrete world and they like that stuff, it's just, I think it's that anxiety about the abstraction that they just won't, I don't know what it is, but it's been curious to encounter that.
And I think they'll be expected to sort of have internalized them when they use logarithms or tangent signs, because that, in its very nature, it's a functional notation. And so that is important. It's not just some formality. It's actually going to help them to understand relationships for which there is no algebraic expression. They need to learn it. Anyway, so.
Thanks, Louis.
Yeah,
You can kick and scream about math all you want.
That was great.